In this lesson, we are going to be graphing quadratic inequalities and graphing systems of quadratic inequalities. So, we are going to be graphing a quadratic just like we've already done using all the steps, except for the fact that now it's going to be an inequality. So when we graph that parabola, if it's less than or greater than, we're going to use a dotted curve or dotted line. And if it is less than or equal to or greater than or equal to, we're going to use a solid line. Then we will test a point, and we will test a point either inside or outside the parabola. If it works, we will shade in that area. If not, we will shade in the opposite section. We will use the same process if we are doing a system of quadratic inequalities, where then we will do the second parabola, test, decide where to shade, and the common shading becomes the solution to the system. Let's practice with first a single quadratic inequality. What we will do is decide whether this parabola opens up or down. In this case, it's going to open down. We need to use a dotted curve as we make our parabola because it is greater than. Now we need to find our axis of symmetry. X equals negative b over 2a. Our b value is 4, so we'll use the opposite of that, which is negative 4. We'll multiply 2 times the a value, which is negative 1. Negative 4 divided by negative 2. Negative divided by a negative is positive, and we get an answer of 2. Now we're going to substitute that 2 into our original inequality, but we're going to make it an equation, and we're going to replace the x with 2. So we have negative 2 squared plus 4 times 2 minus 1. Remember, you're going to square the 2 first, which is 4, and then we have a negative on the outside of that. So we'll have negative 4 plus 8, which is 4, minus 1 is going to be 3. So our vertex, since we already found our axis of symmetry, and we know the x value of the vertex is 2, and the y value we calculated as 3. We're going to make our parent function table. We'll use 0, 1, and 2. We'll square them to get 0, 1, and 4. Because there is a negative in front of our x value, then we know the leading coefficient is negative 1. We need a third column. We're going to multiply everything by negative 1. Remember to cross off the middle column and to circle the 0, 0 because that is where our vertex is located. Now we'll graph our vertex at positive 2, positive 3. And I've already drawn in the axis of symmetry for us at x equals 2. Now we will use our parent function table, and we're going to go over 1 and down 1, reflect it to the other side, and then we're going to go over 2 and down 4, reflect it to the other side. We need to make our dotted line for our parabola, and we need to test a point to see if we shade on the inside or the outside. Notice that my parabola comes very close to 0, 0, so if we're not sure, it might be a good idea to use a point that's right inside the parabola. The point that we could use is right on the axis of symmetry and right on the x-axis. The point 2, 0 would be great. So if I plug 0 in for y, and then I plug 2 in for my x values, I know that 2 squared is 4 times negative 1 is negative 4, plus 4 times 2 is 8, so we have negative 4 plus 8 is 4, and 4 minus 1 is 3. Is 0 bigger than 3? The answer is no. So since that was on the inside of our parabola, then we said no, we need to then shade on the outside of the parabola. Let's take a look at our second example. In our second example, we can see that our leading coefficient is positive. Since our leading coefficient is positive, we know that our parabola opens up. We know that since it is less than, it's going to be a dotted parabola, a dotted curve. We need to find our axis of symmetry by using negative b over 2a. Since there is only an x squared, the leading coefficient is 1, which is our a. That means our b value is 0, and 0 divided by anything is 0. So we're going to substitute 0 in for the x, change our sign to equals, so we know then y is 0 squared, which is 0. Our vertex, our x value is 0, and our y value is 0, so we know that our vertex is at the origin. We will make our parent function table 0, 1, 2, 0, 1, 4. We do not need a third column because our leading coefficient is 1. We will put our vertex at 0, 0, which is the origin. Then we will go over 1 and up 1 and go across our axis of symmetry, which is the y-axis. Then we're going over 2 and up 4, over 2 and up 4 on the other side. In this case, our axis of symmetry is our y-axis, and we know that we need a dotted parabola. We cannot use 0, 0 as our test point because that's our vertex, but I'm going to use a point that's right on the y-axis. So I'm going to pick something that's inside the parabola, and that would be the point 0, 2 that I'm selecting. So 2 is my y value. Is that less than 0 squared? Is 2 less than 0? No, 2 is not less than 0, which is inside the parabola. So we will shade on the outside of the parabola. In our next example, you'll notice that it is in vertex form. So the first thing we want to determine is that our parabola is opening up. We know that this time we're going to have a solid parabola because it's less than or equal to. Our vertex is at the point -5, -3. We'll make our parent function table 0, 1, 2, 0, 1, 4. But this time we do need a third column because our leading coefficient is 2. We're going to multiply everything by 2, and don't forget to cross off the middle column since we have created a third column and circled the 0, 0. That's where our vertex will be. So our first point that we'll put on the parabola is at -5, -3. Notice I've put our axis of symmetry in already. Then what we will do is use our parent function table and go over 1 and up 2, and we're going to reflect that to the other side. And then we're going to go over 2 and up 8, and we'll reflect that to the other side. Then we're going to draw in our parabola. This time we're using a solid line. And we need to test a point to see where to shade. We can shade on the inside or the outside. This time 0, 0, the origin is on the outside of the parabola. So I'm going to test that by plugging a 0 in for y and a 0 in for x. Because it is in vertex form, we need to calculate that. So 0 plus 5 in parentheses is 5. 5 squared is 25. 25 times 2 is 50, and 50 minus 3 is 47. Is 0 less than or equal to 47? Yes, it is. Since that is true and the origin is located on the outside of the parabola, I'm going to shade where the origin is, which is on the outside. Let's move on to a system of quadratic inequalities. The first thing I'm going to do is to divide my workspace into two sections because I have two parabolas that I need to work with. So starting with the top one, which is the first, I need to remember that this is going to open up since it is a positive leading coefficient. I need to take a look at my inequality symbol and notice that since it is greater than, I need a dotted parabola. Next, I'm going to find my axis of symmetry. X is equal to negative b over 2a. The b is negative 4, so the opposite will be 4, divided by 2 times a. A is 1, so 2 times 1 is 2. So my x value is 2. I'm going to substitute the x2 into my inequality. So I have y, I'm going to change it to equals. I have 2 squared minus 4 times 2 minus 4. 2 squared is 4. 4 minus 8 is negative 4. And negative 4 minus 4 is negative 8. So my vertex is at 2, negative 8. Now I'm going to do my parent function table at 0, 1, 2, and 0, 1, 4. And I don't need the third column because my leading coefficient is 1. I'm going to graph at positive 2, negative 8. My axis of symmetry is at positive 2, and then I'm going to do negative 8. Then I'm going to use my parent function table. I'm going to go over 1, up 1, reflect it to the other side. Then I'm going to go over 2 and up 4 and reflect it to the other side. I am going to use a dotted curve to connect these together. And you'll notice that my point origin 0, 0 is located inside the parabola. So I'm going to test 0, 0. For the first inequality. Is 0 greater than negative 4? Yes, 0 is greater than negative 4. So I'm going to shade on the inside of the parabola at 0, negative 4, where that's located. So I'm shading on the inside of the parabola. Next, I'm going to do my second inequality. My second inequality is going to go down. It is going to be a dotted parabola. I'm going to find my axis of symmetry, which is negative b over 2a. 2 times negative 1 would be negative 2. So the x value is going to be at 2. I'll go down here and I'll plug that in. So I have y, and I'll change it to equals, negative, and I'll plug the 2 in, squared, plus 4 times 2 plus 4. Negative 2 squared is 4 times negative would be negative. So negative 4 plus 8 is 4, and 4 plus 4 is 8. So my vertex for this particular parabola is going to be at 2, 8. I will make my parent function table at 0, 1, and 2, 0, 1, and 4, and this time I need a third column because my leading coefficient is negative 1. 0, negative 1, negative 4, crossing out the third column. So as I graph this, my vertex is going to be at 2, positive 8, and then I will use my parent function table and go over 1 and down 1. And I'll go over 2 and down 8. Or excuse me, over 2 and down 4. And I'll reflect it to the other side. So now I'm going to draw in my parabola with a dotted line. And we're going to test the point 0, 0. Is 0 less than 4? And that is true, yes. So that is going to be on the inside of that parabola, which is opening down. So I'm going to shade on the inside, and so you can see that when we're shading on the inside of both parabolas, it makes kind of this oval section in the center, which is the solution to our system of inequalities. Let's take a look at one more example. So we have one more system. I'm going to draw my line down the center. If I take a look at my top inequality, notice that it's negative, so it's going to open down. It has an equal sign, so it's going to be solid. We'll find the axis of symmetry, x equals negative b over 2a. In this case, the b value is negative 8, so when we change it to negative b, it will be 8, divided by 2 times a, which is negative 2, negative 4. So this is going to equal, x is going to equal negative 2. Then we want to find our vertex. We're going to find that by plugging in the negative 2 into our top inequality and setting it equal to y. So we have negative 2 times negative 2 squared minus 8 times negative 2 minus 6. Negative 2 squared is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is positive 16. When we add those together, we get 8 minus 6 will be 2. So our vertex is going to be at negative 2, positive 2. We'll make our parent function table 0, 1, 2, 0, 1, 4. But we need a third column because we're multiplying it by negative 2. So we get 0, negative 2, negative 8. And we'll cross off our third column, circling our 0, 0, where we know that at our 0, 0 is where our vertex is going to be. So we'll have our vertex at negative 2, positive 2. Using our parent function table, we're going to go over 1, down 2, reflect it to the other side, and over 2 and down 8, and reflect that to the other side. We can use our solid line to draw in our parabola, and we're going to test 0, 0, because that is on the outside of the parabola. Is 0 less than or equal to negative 6? No. So we are not going to shade on the outside of the parabola. We are going to shade on the inside of the parabola. All right, let's finish up our last example. We take a look at our last inequality, and we know that it opens up because it has a positive leading coefficient. We know that it is a solid curve for our parabola because it's greater than or equal to. We'll find our axis of symmetry, negative b over 2a. So it's going to be negative 2 over 2 times 1. which is going to equal -1. We're going to find our vertex by plugging in the -1 for the x value. So we have y is equal to -1 squared plus 2 times -1 minus 4. -1 squared is 1. 2 times -1 is -2. 1 and -2 is -1. Minus 4 is -5. So our vertex is at -1, -5. We'll make our parent function table at 0, 1, 2, 0, 1, 4. We do not need a third column because the leading coefficient is 1. So we will graph our vertex at -1, -5. Using our parent function table, we'll go over 1 and up 1 and reflect it to the other side. And then we will go over 2 and up 4 and reflect it to the other side. And we have a solid line that we are going to use to draw our parabola. I'm going to test the point 0, 0 because that is inside our parabola. And using the second inequality, we plug a 0 in for the y. Is that greater than or equal to -4? Yes. So we can shade on the inside of our second parabola. And when we do, you'll notice when you shade on the inside that this part right here is what they would have in common. So I'll make that a little bit darker right in here, and that would be the common shading, which would be the solution to our system.